Alright, so the first question on this side is talking about the two noisy communication channels thing from the tutorial. So it's just way to basically broad body question. So it's kind of like a repeat question. So it's the same steps to do it, nothing else changed in the question itself. So skipping all the blah blah blah. They said that you have a channel 1 input of X and the output is Y, and then the input of the other one is the output. So Y is technically the input of something else. So you have X0, X1, and then that'll go into Y0 and Y1, and Y0 and Y1 is the input to Z0 and Z1. That's basically what I'm trying to tell. So you know your lines will join here, then we'll go down to Y1, then this will go across here, and then this will come up like that. And then for the second one, yeah, Y0 go to X0, Y0 to X1, Y1 to Z1, and Y1 to Z0. That is the connected channel there. So in the question, they gave you some probabilities. So they said the probability of getting Y1 given that you send X0, which is this. So the probability of Y1 given X0, and they said that is 0.3. So that is here. And the second one, they said the probability of Y0 given Y1, so the probability, sorry, X1, so that'll be here. So probability of Y0 given X1, and that is 0.6. Alright, and then they said for channel 2, the probability as Z0 given Y0, which is up here, is 0.2, and they said the probability as Z1 given Y1, this one, yeah, the Y1 is down here, so the probability of Z1 given Y1 is 0.6. So let us make sure the probability of Y0 given X1 0.6, we have that. Y1 given X0, we have that. And for the Z's, Z0 given Y0, alright, and then Z1 given Y1 is that. So we can find the other transitional probability. So for this one, the probability of Y1 given X1, and up here, the probability of Y0 given X0, and it's just the remaining piece from the probability that they give. Because remember, it's how to add up to 1, right? So in this one here, Y0 given X1 is 0.6. So Y1 given X1 will just be 1 subtract 0.6. Because the two coming out how to add up to 1. But the sum of the probabilities have to add back up to 1. And it's the same thing for the other one. So the probability of Y1 given X0 is 0.3. So the probability of Y0 given X0 will be 1 subtract 0.3, which is 0.7. Now we can do the same thing for the channel 2. So we have here the probability of Z1 given Y0. So that'll be the remainder from this, from 1, which is 0.8. And then you have this piece up here, which is the probability of Z0 given Y1. So it'll be the remainder from this here. So it'll be 1 subtract 0.6, which is 0.4. So there's your output, and this is your system input. So this is the connected binary communication channel gate. Alright, so that's that. So the first question said, what is x1? So at the end, they said the probability at x0, which is here, they said is 0.25. So the probability of x1 would just be 1 subtract 0.25. Remember, the sum of the probabilities must add up to 1. If x0 is 0.5, x1 had to be the remainder. So that was that. B, determine the other transition probabilities. So we already calculate those. So if you had to put and do it in the exam to get marks, you could write it like the probability of y1 given x1 is 1 minus. So the y1 x1 was here. So it will be 1 minus the probability of y0 given x1. Because I already did up here. We just did it before the asked question. So it was 1 subtract this. So you get 0.4. And you can do the rest in terms of the equation for that'll be y0 given x0. So it'll be 1 minus, where that's y0. So we have subtract the 0.3, which is this one here. So 1 subtract the probability of y1 given x0. And that will be 0.3. And I just repeat the same kind of steps for the z on the side. So the other z's I don't want is the probability of getting z0 given that is and y1. That is 1 minus the probability of z1 given y1. That's what they gave us. The last one, what they're asking for is the probability of z1 given y0, which is 1 minus the probability of z0 y0, and I think we had get 0.2. We had done that before, so we just stating the equations. Alright, and then part C, determine, well, the probability of y0, y1, z0, and z1. So the probability of getting y0 will be the sum of the lines that come into it. Nothing more, nothing less. So you just adding them up. So the two that come in will be the probability of y0 given x0 by the probability of x0. And then this one here is the probability of y0 given x1 by the probability of x1, which I think we had as 0.75. So that's really all this is. You just adding up the sum of the lines coming in. So probability of y0 will be the probability of getting y0 given that you send x1 by the probability of x1 plus the probability of you getting y0 given that you send x0 by the probability of x0. That's basically what it was. From the diagram, y0 x1 is 0.6. Probability x1 is 0.75 plus y0 x0 was 0.7 and the probability of x0 was 0.25. So when you plug that in the calculator, it's supposed to get 0.625. Alright, and then the probability of y1, because the probabilities had to add up to 1, it would just be 1 minus the probability of y0, so it would be 1 minus 0.625 and end up with 0.375. If you wanted to, you'll get the same answer, but you could do the same thought process with this one. So that'll be the probability of y1 x0 multiplied by the probability of x0 plus the probability of y1 x1 by the probability of x1. And you'll end up with the same answer for the probability of y1. So then the wanted, now the probability of z0, so it'll be the same thing. So it'll be the probability of z0 given that is sin y0 by the probability of y0 plus the probability of z0 given that is sin y1 by the probability of y1. Remember, you're just adding up the sum of the lines that are coming in. So for z0, the lines are coming in with the probability of z0, y0 by the probability of y0 plus the probability of z0, y1 by the probability of y1, which you already calculated before. So here, so probability of z0, y0 is 0.2. So it'll be 0.2. The probability of y0, 0.625 plus, so z0, y1, 0.4. And the probability of y1 was 0.375. Alright, so go ahead and calculate that now. 0.625 by 0.2 plus 0.4 by 0.375. Here is 0.275. And then the probability of z1 would just be 1 minus the probability of z0, which is equal to 1 minus 0.275, and you get 0.725. Alright, so that was that. And the last question, the probability error. So the probability error is the probability of you getting what you didn't send. So if you send 0, so it's get 0. If you send 1, so it's get back 1. If you send 0 and get 1, that is an error. If you send 1 and get 0, that is an error. So in that case, for channel 2, the probability of you getting z0, given that you send y1 by the probability of y1 is an error. Because you send y1 and you get 0. Plus the opposite. So it should be you get z1 but you send y0 by the probability of y0. So it's the sum of the lines that you don't want. So you send y0, you get z0, that's good. You send y1, you get z1, that's good. But in the middle is your error. The ones are intersected. Okay, you don't want those, because that means you send y0, but you get z1. You don't want that. So that's an error. That's the sum of the ones that you don't want to get. So this here, the probability of z0 given y1 is 0.4. The probability of y1, I think we have 0.625 plus z1 y0. So z1 that is 0.8 by 0.375. So it'll be 0.4 by 0.625 plus 0.8 by 0.375. And it gets 0.55 for the probability R. And the probability of it working would just be 1 minus the probability of the error. That is all that was. And that was the first question. Alright. Any questions on it? I think it was straight from the tutorial. So. Okay, nice. Question 2. So question 2 is a continuous random variable question. So I'm gonna do it how I show you, so you'll see it's not as difficult. If you bring like this, you'll be happy. Because the same thing again, a little bit of integration. So I run through. So the probability density function of a continuous random variable is given by this. Okay, sketch the PDF. Okay, so the PDF already gave you the PDF as a piecewise function. So the ranges again was 0, 1, and 2. So they said between 0 and 1 is a 2. Okay. And then from 1 to 2 is 2/3. and 0 otherwise. So that was that. I think it was, well, that is it. That is all. Say label the axes x, and that is a PDF, which is A. And then for B, the corresponding cumulative density function. So I'm gonna do it how I show you. So what you do, show a line indicating the line in terms of the probabilities I could get. So it going from minus infinity to infinity. Then you plug in the ranges at the heart. So it has 0, 1, and 2. And then you plug in the ranges that it gives. So between minus infinity and 0, obviously is 0, but I say 0 otherwise. Then from 0 to 1, it was a third. And then from 1 to 2 is 2/3. Okay, so what you gonna do? You gonna start from here, and you gotta move in this direction. And then cumulatively adding up some of the probabilities in the different regions. Right, everything will just come together. And how you know this was correct, and how you know you for sure get the correct answer, is because the last region, the cumulative density function will equal to 1. So that's how you will know if you're going correct or wrong. Yeah, so they're run through. So the first region you start in here, so remember use x. So you are x. You moving through the line because you are x. And that adding up the sum of the probabilities at and before it. Remember it's continuous, so you might have to integrate somewhere. But like, so the first region is if the x is less than 0 but more than minus infinity. That one easy. So that one is 0. Because obviously it have nothing here. It could be the integral. If you want to be technical, it could be the integral from minus infinity to x. Remember x anywhere inside this region here. And then it will be integral as 0, which should get 0. Yeah, so that is the first region. So that is if x was in between minus infinity and 0. The CDF for that would have been 0. So that is your first region. So that is region 1. Your second region now. So your x going and let me say the x somewhere in between 0 and 1, like the next region. So the next region will be x is less than 1 and more than 0. So it'll be region 2. So region 2, so capital F of x, that will be the integral from minus infinity to 0 as 0 dx. Because remember you add here, you can just put 0 if you want, that is being technical. And then plus the integral from 0 to x, anywhere in between. And anywhere in between here is at 2 dx. You could put 0 here. I'm just showing you how it cumulatively adding up the probabilities, which would be the area for continuous random variables, right? So here now, this would be 0 plus, and the integral of a third is a third x between x and 0. So for this one, it will just be, when you plug x into this, you'll get x minus 1/3 by 0, which is 0. So you get us end up 1/3 x plus 0. So between 0 and 1, it will be this line, but our y-intercept of 0. So everything coming together. So now, region 3. So let you see where region 3. So we pass 1, because we already account for between 0 and 1. So let us say if x in between 1 and 2, what will happen to the CDF? So that would be when x is less than 2 but more than 1. That's so that's the range of it. So the CDF will be the integral from minus infinity to 0 of 0 dx plus the integral from 0 to 1 of a third dx plus the integral from 1 to x of 2/3 dx. So you see how the integrals adding up cumulatively. You could just put 0 plus a third, you'll get the same answer. It's the same thing. I just write it so you could see how the area is building up cumulatively up to what you want. And all this here will literally just give you the equation or the line in between them two bounds. It's real easy. Because once you do this, you have a full proof where you're getting the answer. So here, this is 0, obviously. This here is a third plus. And then this here, integrate 2/3, you get 2/3 x. And between x and 1, so you get 0 plus a third, and then plus 2/3 x. And then when you plug 1 into this, it's going to be minus 2 and 3. Remember, it's b subtract a. So b in this case is x, and subtract a, which is 1. So that we get the minus 2/3 from. So the capital F of x for this will be 2 on 3x, and then 1/3 subtract 2/3 will be minus 1 on 3, and that is the equation for those two bounds. And the last region, which is region 4, so that is if x is less than positive infinity but more than 2, because that will be if x go on past, so here now, so you went through the whole thing. So that there will be the integral from minus infinity to 0 of 0 dx plus the integral from 0 to 1 over 3 dx plus the integral from 1 to 2 of 2/3 dx plus the integral from 2 to wherever x is, and the area there is 0, but then this has 0 otherwise. Okay, so all this here, this is 0, this is a third, this is 2/3, this here is 2/3, and then this here will be 0. And all in all, you get 1. So we good. Once you end up with 1 at the end, you're safe. Because the CDF for continuous, it always plateaus at 1. You're supposed to plateau at 1. If you don't, that means you're missing an area. Well, if you do this for the line, you can see all the possible intervals x could fall into. So if it's less than 0, between 0 and 1, between 1 and 2, and from 2 to, well, it depends on what ranges she will bring. Alright, so let's sketch it now. So now we can sketch it. So that's what she say, find the CDF, and you can sketch it now. So we have 0, 1, and 2. So let's go back. So we have a range from 0 to 1, 1 to 2. So we know it plateauing at 1, so just put our 1 there for sure. Okay, so let's see how it's between 0 and 1. The equation was 1/3 x plus 0. So why it's up at 0? So if it's 1/3 x and it ending at 1, you expect the final value to just be a third. So you get that value right there. Because it's a line, so it have a beginning and an end. So it ending at 1. So you just plug 1 into the equation for that region, and you get where it ended. So you know it here. Then the second region now is between 1 and 2, and that was 2/3 x minus 1 and 3. So minus 1 and 3 here, and then 2/3 x is this line. So if you want to know what value it will end at, it's supposed to end at 1. So you have 2/3 x, subtract 1 and 3, you plug in 2 as x, but I will ending. So 2 by 2 is 4 and 3. Subtract 1 and 3, which is 3 and 3, which is 1, which is correct. Okay, it's supposed to end at 1. So it will be a little steeper because there's the minus up here. So we're gonna go up here, and then obviously from here now, you plateau. Because if there's anything more than 2 or 3 or whatever, It's supposed to be 1, which is what we get here. If x falls between positive infinity and 2, is 1. So no matter what we have our answers here. So plug in the axes, x, capital F of x, and that is your CDF. That's how we just do it. Alright? So that's that. 10 marks. Wow. Okay, mean and variance. So the mean, like you say, E expectation, the same thing. For continuous random variables is the integral from minus infinity to infinity, which is the total area under the graph, x by f of x dx. That's what it is. For variance, well, we're going to do variance when we get to the variance part. So for this part, you're integrating the PDF. So when you have two ranges, so it could be the integral from 0 to 1 over third x dx. Remember, we had to multiply the x by each of them. So it'll be 1/3 x and 2/3 x. Now what do I mean by x f of x? Plus the integral from 1 to 2, 213x dx. So this piece here now, we have 1. So x, you add 1 to x, we get 2. So 3 by 2, supposed to be 6. But I would integrate. So add 1 to here, we have 2, and you divide by the same thing. So between 0 and 1 plus 2. So add 1 to 1, you get 2. And 3 by 2 is 6. Between 2 and 1. So 1, when you plug 1 into this, you get 1 and 6. 0, you get 0. So it'll be minus 0. But I'm not just going to skip it. Plus, and then this piece here, 2 squared is 4. 4 by 2 is 8. And then you subtract. Plug 1 into this, 1 squared is 1. 2 by 1 is 1. So you get subtract 2 and 6. All in all, 8 plus 1 is 9. 9 minus 2, 7 and 6. And that's the expectation. And the variance is equal to the integral from minus infinity to infinity of x squared f of x dx. So the variance is x squared and the expectation is x. So same idea, we integrate it, but instead we use x squared instead of x. So it'll be integral from 0 to 1 of 1/3 x squared dx plus the integral from 1 to 2 of 213x squared dx. Alright, so here now will equal to 2, so it'll be 1 and 9 x cubed, because 2 plus 1 is 3, 3 by 3 is 9. Well, they go to the integration plus, and this one here will be 2 and 9 x cubed between 2 and 1. So this here will be 1 and 9. It'll be 0, so I can skip that. Then this here will be 2 cubed, which is 8, because 2 2s are 4, 4 2s are 8. 8 by 2 is 16 and 9. Subtract, and that'll be 2 and 9. So 16 plus 1 is 17. And 17 subtract 2 is 15 and 9. And that is a variance of x. And the last one, the probability that x is less than 1.5, more than 0.5. So more than, less than, or equal to, all the equal to's for continuous, it can nullify. So when you're doing questions for continuous only, less than and less than or equal to, it will be the same value initially. You don't need to hot up your head and say less than or equal to for continuous. You just use the number. Because we're going to use 1.5, 1.499999. It doesn't really make any sense. It's continuous. So for this one, this will be the same as saying the probability 0.5 more than or equal to x, like 1.5. You could write this in any other way. So probability that x is less than or equal to 0.5 and less than 1.5. Any other way you choose to write it, will be the same calculation. So don't let the signs itself, if it equal to confuse, it will be the same steps all in all. But for discrete, care about it. Because for discrete, if it's less than 5, you gotta start at 4. Because it have nothing in between 4 and 5. So just keep that in mind. Don't let it confuse you. Just go through your normal calculations with the numbers that they give you. So because we have a CDF graph which gives us the probability x being less than or equal to x, you just use that. And because I have a line, my line will also help me out because I can see what I want. So they want to say there's 0.5 and there's 1.5 here, so I'll use. So if I plug in 1.5 into my CDF equations, I will get everything less than or equal to 1.5, which is okay. But then if I plug in f 0.5 into my CDF, I will get everything less than or equal to 0.5. So if I just subtract, so I could say capital F or 1.5, which is everything less than or equal to 1.5, subtract F as 0.5. When that just gives me what I want, which is the one in black, yeah, we'll give me what I want. So I'll do that. Because remember, I have a CDF, so I could use it. Right? Okay, that's carbon out where you don't want from where you want. Or carbon out where you want from where you don't want. That's carbon. So this here will be everything less than or equal to 1.5, subtract everything less than or equal to 0.5. So 1.5 is between 1 and 2. So we got to look for the equation between 1 and 2. So which is here, I think was 2 third x minus 1 and 3, which is here. But as the beauty here, getting the CDF equations with the ranges, with the regions. Okay, you can use it. Remember, the CDF has given the probability less than or equal to a specific value. So here, it will be 2 thirds multiplied by was 1.5 and subtract 0.33. So I get 0.67 and 0.5 is in between 0 and 1. So that'll be up here, 0 and 1. So that'll be 1 third. So it'll be 1 third multiplied by 0.5. So it'll be 0.166, whatever. Better to work in fractional form. So if you have a Casio, you'll get a more accurate answer. So that will be 0.67 subtract 0.167 and you get 0.503. And that is it. You come up where you want from where you don't want or whatever, and you get answer. CDF gives you the probability less than or equal to a specific value. And that was number 2. Right? Okay, if no questions, let's continue. So last one, so which is a discrete random variable question. So it's the same question from my tutorial, just scaled up a little bit. So same idea really, not really change. So our information so generates symbols at random from an 8-letter alphabet, A to H, with probabilities, well, they give you all the probabilities from A to H. Our coding scheme encode these symbols into binary codes, alright. Okay, important line. X is the length of the code. That is the number of binary symbols, whether it be 0 or 1. So x, the random variable x, is the length of the code. That is your possible values that you're using. Yeah? So there you go. So the first question is calculate the PMF. So they use PMF for discrete and PDF for continuous. It's the same idea. Alright? So don't let it confuse you if you see mass. So let's see. So I want to use a table. So the possible values are x. I could have 0 bits. I could have 1, 2, 3. I could have 4, 5, 6, 7, or 8. That is the possible values I could have. So then I have the probability that x is equal to x. So the probability of you having 0 bits is 0 because it's not really giving anything for that. Having 1, which is this here, is A, which is 0.3. Getting 2 bits is B, which is 0.2. Getting 3 bits is C, which is 0.15. Getting 4 bits is D, which is 0.1. Getting 5 bits, 1, 2, 0, 1, 2, 3, 4, 5, is E, which is 0.1 again. And you probably catch the idea by now. So I can go waste your time. And 8 is 0.03. 8 is H, which is here. So you just match it. If they had one where it's like here, so to have 2 letters that have the same amount of binary digits, it will be B plus C. So the probability x is equal to 3 will be B plus C. And same thing if it had others that had the same amount of binary symbols. So that would be the sum of both of them. So if I add a 1 here, the probability x is equal to 5 with the probability at D plus the probability at E. So luckily for us in this case, she gave us it, just increase them by 1 each time. So each one will be whatever it was given to on top. So she kind of helped all out in that case. So this is here PEMF values. So we should know to put the PEMF by now. So you have the graph. So we know it's supposed to plateau at 1. So we put the 1 there for now. Start at 0. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. So it's discrete, so it will be dashes on top. I should not have written the 1 because that is for CDF. I don't need this for this one. But the sum of each of them will be 1. But that is only for CDF, line up for P. So at 0 is 0, at 1, what else? Zoom out. At 1 is 0.3. At 2, I think I can see everything. Right. At 2 is 0.2. 3 is 0.15. 4 is 0.1. 5 is 0.1. 6, 0.07. Here is 0.05, and down here is 0.03. Okay, so that's that. That is your PDF. So common f of x, and you have x here. So that is discrete. That is how it does draw the PDF or PMF for discrete. So that was A. So then B, or the action. So plot the, anyway, calculate the plot for the CDF. So if we come back to the CDF, we could just use the table. So remember, the CDF is the probability that x is less than or equal to a particular x value. So we could just run through the table like this. So at x, the probability x is less than or equal to 0 is 0. The probability x is less than or equal to 1 is the probability at 1 plus the probability at 0. Remember, it's less than or equal to. So it'll be 0.3. 2 going to be 2 plus 1 plus 0, which is 0.5. All right. Then you have 3, which is 3 plus 2 plus 1, which is 0.65. 4 is 4 plus 3 plus 2 plus 1, which is 0.75. 5 is 5 plus 4 plus 3 plus 2 plus 1, 0.85. 6 is 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0. So that will be 0 point, and it will be 9.2. 7 is 7, 3 to 0. I'm not going to repeat all them values. So it'll be 0.97. And 8 will be 8 plus all the values before. And it's supposed to add up to 1. The final value always supposed to be 1. for a CDF plot. That way is not going correct. It's very hard to not get one. So if you're not getting one, you most likely make a mistake somewhere. Okay, so we have our CDF plot. Oops, so I go through. So this is the one where I could put the plateau at one for sure, because I see that. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. So let's see. So at 0, everything less than or equal to 0 is 0. At 1, everything less than or equal to 1 is 1. So it'll be 0.3. So that's why it is. So I will write the dot. Everything will make sense in a bit. So it'll be 0.3. And then at 2 is 0.5. Then at 3, 0.65. So 3 is 0.65. Then at 4, 0.75. And then 5 was 0.85. And then 6 was 0.92. And then you have 0.97. And then 8, you have 1, which we know that just plateau off because you had 1. So that's how I just do it, right? So I just put the dots. Then you could just use flat lines. So everything less than or equal to 1 is 0.3. Everything less than or equal to 2, 0.2. Come down. 3 will be this. Come down. 4 go across. Come down. 5 across. Come down. 6 across. Come down. 7 across. Come down. And then this one up here, which is what we had start. So just show the dot. So it'll just be across, come down, and we know this one and just stay at 1. And that is the CD. So I'll do the dots and just do the stairs after. So you can kind of see it better. That's how I see it. Either way, there are multiple ways you can do it. So there's capital F of X. This is X. And that is a CDF plot. And then where is the mean? Okay, so the mean of a discrete random variable is sum. You can say k is equal to minus infinity to infinity. So it will be the sum of x by the probability x is equal to x. So you're adding up. So in this case now here, which is why I normally use the table for discrete, because I normally is gonna ask for all this. I can just use my table. So this says the probability of x by the probability x is equal to x, which is just you multiplying the x by here. So 0 by 0 is 0, 1 by 0.3 is 0.3, 2 by 0.2 is 0.4, 3 by 0.15 is 0.45, 4 by 0.1 is 0.4, 5 by 0.1 is 0.5, 6 by 0.4, sorry, 6 by 0.07 is 0.42, 7 by 0.05 is 0.35, and then 0.03 by 8 is 0.24. Then the sum x by the probability x is equal to x. It could be adding up all that. So 0 plus 0.3 plus 0.4 plus 0.45 plus 0.4 plus 0.5 plus 0.42 plus 0.35 plus 0.24. Phew, I got 3.06. Okay, and then what else we want? That was the mean. So we got 3.06. My apologies. And then the last, second to last one, the variance of x. So that there's the expectation of x squared subtract the expectation of x all squared. Okay, so all squared. So the only thing we don't have here is this one here. So we have to calculate the expectation of x squared, which is just the same thing, but just, so it could be the sum of from k is equal to minus infinity to infinity, x squared by the probability x is equal to x minus, and this was the sum, minus infinity to infinity of x by the probability x is equal to x, and this whole thing being squared. We already have this value, which is up here. The only thing I don't have is this one here. So it's x squared by the probability x equal to x. So, so I could just chuck in our x squared column here. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and 8 squared is 64. And then we add in our next column, x squared by the probability x is equal to x. So this here is 0, 1 by 0 0.3 is, sorry, 1 by 0 0.3 here is 0 0.3. Then 4 by 0 0.2 is 0 0.8. 9 by 0 0.15. So that'll be 1.35. Then 16 by 0 0.1. That'll be 1.6. Then 25 by 0 0.1. 2.5. I'll follow this carefully. 36 by 0 0.07. So we'll get 2.52. X 49 by 0 0.05, 2.45, and then the last one, 64 by 0 0.03, and you get 1.92. And now the last thing we have to do is get the sum of x squared by the probability x is equal to x. So we add all that. So it'll be 0 plus 0 0.3 plus 0 0.8 plus 1.35 plus 1.6 plus 2.5 plus 2.52 plus 2.45 plus 1.92. And we end up with 13.44. And you know, if I make an error there, but we're true. So therefore, we have 13.44. So we could finally get the variance. So that'll be 13.44 subtract the expectation squared. Put in a calculator, so answer subtract 3.06 squared, and you get 4.07. Alright, so that was that. Let's say let's find the variance of discrete. So in this one, we went to the expectation variance for discrete and continuous. So let's be careful with random integration for discrete. So you know which one you're doing for sure. And the last question of the night, find the probability that there will be at least 5 bits. So the probability that x is more than or equal to 5. Let us say at least. That there, I will carve out what I don't need. So the 1 minus the probability that x is less than or equal to 4. Okay, remember, more than or equal to 5, you add 5 already, and you're including 5. So everything that I do want to be 4, 3, 2, 1, 0. So it'll be 1 subtract what I don't want. So it'll be 1 subtract. Should be able to use the CDF to get this, because we have a table with everything. So less than or equal to 4 would be for the CDF, yeah, which is here. Less than or equal to 4, which is 0.75. And you just end up with 0.25 for the answer. And that's it. That is really all it is. 1 plus the 17, 19, 20, 20. Yeah, so if you wanted to, you gotta just add 5, 6, 7, and 8. You'll still end up with the same answer, which is 0.25. But why do that? You have a CDF already. And that there is the end of 2023 midterm for probability. So I hope it was helpful. If you'll need anything, you could message me. If you'll have any questions on anything here, I'll send you all these documents with the solution. So all the best, and we will talk. So we start in vectors Saturday coming. I know that what I want, so we're looking to push. All right, so all the best, and we will speak when we speak again.